Hello, my name is Gonzo, and what we're going to do over the next few videos is we are going to build from scratch a model for predicting the outcome of football games. And you can take this in a number of ways. Okay, we're going to be building it in Python. We're going to be using some core data science principles to do so. And then we're also going to be benchmarking it against both the actual results that occurred and other people's opinions in the market. So we're talking there about how bookmakers represent their probabilities and whether or not, if you bet on this model, would it have made money. This video is the first one in the series, and what we're going to do is we're going to set up our environment and we're going to pull in the data and give it a little bit of a clean. Going forward from that, we need to build out some of the tools that we're going to use to be able to analyze the results and the data. We're going to build a little bit of a model to see how we could predict football scores going forwards, and then we're going to benchmark it, like I say, against both the actual results that happened and the market. But in this very first video, we're going to pull in the data that we need, we're going to clean it, and we're going to build, I think, a little bit of the tooling that we will require to make our lives easier going forwards. We are building this from scratch, like I say, in Python. All the code will be available in my GitHub for you to take, for you to adapt, and for you to play with going forwards. But for today, let's dive into it. Okay then, right, starting very much from scratch. I'm in the terminal here, and you may have a different way of doing a couple of things I'm about to do, but the principle is broadly the same. We're going to create a new directory, and we're going to set up an environment to play in. The tool that I used in order to do this is something called of, or UV, which is a Python package manager tool. I have my own reasons for using UV, which is largely that it avoids some complications with how Python versions mash together, and I quite like the zippiness of the tool. But if you're just going to use something like venv using pip, that is completely acceptable. But we have to create a new directory, which we're going to call football modeling, and then we are going to set up a Jupyter environment inside that so that we can get ourselves a notebook, and using that notebook we will then do some actual modeling in data science. So we are going to make a directory called football modeling, and then we're going to cd into that. So we're going to go into the directory, and I'm going to set up a UV project right here. That is created, so now we have a UV project in that environment, and the first thing that we're going to do is we're going to add some of the packages that I know that we are going to need. So we're going to need a package called pandas, which is a data manipulation program in Python. Oh, no, that's not how you do it. You add pandas. And then I also know that we're going to need NumPy, which was already there because pandas brought it in, so that's good. And we are going to need UV add Jupyter. That is going to add itself, just like that. Once that has occurred, what we can do is we can run UV run Jupyter lab, and that will open up a Jupyter Notebook environment for us to play in. Give it a second, and it has shown up in the Safari browser that I've got just here. Now, there are some files in this that we don't need, so we don't need hello.py. If we open that and inspect it, you can see that UV adds this Python file in there. There is also a thing called the pyproject.toml, which is a little bit like the requirements.txt, but it's slightly more complicated because it can be mapped to different versions of Python. What this is not really important for this project at all. So we're going to get rid of hello.py. We need to keep the pyproject.toml. Don't delete that. But we can get rid of this, and then we can start ourselves a new notebook. And the kernel I want is the IPython kernel, which exists already. So it's probably worth saying broadly what we're going to do today. What we're going to do is we're going to get some data that is available to everybody, pull it in, have a little bit of an inspect of it, and build the beginnings of the tooling that we are going to need in order to be able to properly analyze this data. So where we are going to get our data from is a website called footballdata.co.uk. You can go there, you can get this data. This is all free. One of the fundamental groundings of this course that we're building out is that you can do these things as well. This is a website by a guy called Joseph Buchdahl, who is kind of a giant in the sports modeling community. He has a number of books. I actually kind of recommend Monte Carlo or Bust as a bit of a read. It's very, very good. But what we're interested in today is his historical data. Now, he provides for free a number of CSVs over lots and lots of different leagues in the world. You can see here we've got English, Scottish, German, Italian, yada, 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 loads of them. We're just going to pull in the English ones today, but we're going to build ourselves a tool to make that as extensible as possible. So clicking on the results, you can see that if we were to go here, you can actually, your browser will download these results for you in this CSV format. Now that's unacceptable to us. We need a programmatic way of pulling these things in. What you can do as a first order thing is point pandas at it. So we're going to import pandas as PD, which is just a standard way of importing pandas so that everyone knows what we've got. And what we can do actually is read this CSV directly from the web and have a look at it. So we can say that our data frame is pd.readcsv, and then we can stick in the web address just here and read that directly from that endpoint into our data frame as a CSV. And if we look at it using df.head, which is a very useful command if you just want to look at the first few rows of data to see what you've got, we can see that we have loaded that in. We've got the division, which is E0, so that's the Premier League. We've got the date that the game happened, the time, the home team, the away team, what actually happened, the full-time home goals, the full-time away goals, the full-time result, so that is home when the home team wins, it's away when the away team wins, and then there's also D for draw. There's then a whole bunch of other statistics, and you can see here that our data frame is being truncated because there are too many columns for pandas to display by default. So one of the first things we're going to do is change the behavior of this notebook to display all of the columns by default because we are perfectly capable of scrolling. In order to do that, we're going to copy in two of the commands I have from my notes, which are setting the options in pandas to display max columns as none, which means it'll display all the columns, and display max width, sorry, just display.width as none, which again will just give us that ability. So if we rerun those things and then we inspect the head again, you can see that a whole load more data has come in for us to look at, and we can scroll through it. We'll talk about what all these columns mean in a moment when we get into more of the data and how we're going to manipulate it. But suffice to say that there's lots of stuff here. So there's the referee, there's the shots, and then we have what the bookmakers thought about these games and some of the different lines. We're not going to deal with all of those for now. What we will need to do, though, is bring in more than one season and potentially more than one league. Now, the naive way to do this is to create lots and lots of data frames. So we might go back to footballdata.co.uk and get another of the links to the data frame and then just stack them on each other. Sorry, that is completely the wrong link. Where are we? Historical data. Apologies. This is how actually these are going to go. These are much more stream of consciousness and less polished than you might be used to in other tutorials. I'm actually going to do it live so that you can understand fully the things that I am doing. Anyway, back to stacking things together. Naively, what you might do is you might go to historical data and you might go, okay, well, I would like not just the Premier League for 2024-2025, I would also like it for 23-24, and we could grab that link and we could go, well, df1 is then pd.read.csv this. And you can see they're slightly different, right? That one's 24-25, sorry, and that one is 23-24. And then we have df1 and our original df, and what we could do is we could stack those together. Then we would have more data. However, that would mean that we had to know every single link every single time, and if we added more data, that would be problematic. So what we're going to do instead is we're going to run through all of the links we know exist because they are programmatic, right? You can see that these change in a predictable way. The thing that changes is the name of the league, which is E0 or E0, and the date, which is 23-24. And so what we're going to do is we're going to set up and create multiple links in a for loop and then read in those individual data frames and stack them together like that. So I happen to know, right, because I've done this in my notes, but also you could probably figure this out for yourself, that the base URL that we're interested in is looks like this. So we're going to have the base URL is equal to And we're going to create what's called an F string here. And what an F string is a way of, in Python, manipulating a string using external variables. So we're going to insert external variables into this. Our base URL is https://www.footballdata.co.uk/mmz 4281 / and then what we're going to do here is we're going to say season and then /league .csv. That is our base URL, and it's complaining here and it's saying season and league are not defined. So what we can do is we can say here, well, the season that we're interested in is 24-25, and the league that we're interested in is E0. And at this point, we can now say, if we inspect what base URL actually is, we now see that we have reconstructed this base URL from up here. The power comes, though, if we have a for loop and we create different seasons and different leagues. So what we're going to do is we're going to set up a list that has the names of all the seasons that we're interested in, and also a list that has the names of all the leagues that we're interested in. Now, we're going to restrict ourselves to the Premier League for now. When this gets more complicated, we'll expand out into other ones, but let's just prove that this works with the Premier League. So the season list that we are interested in is, and we're going to create a list in Python. Let's go from, I don't know what feels good, 2019. Let's start there. So we're interested in 19, 20, 20, 21, 21, 22, 23, 24, and then the final one was 24, 25. So 24, 25. So that is our season list, and our league is just E0 for now. So for season in season list, what we're going to say is that the base URL is that. Let's just move that to here. So we'll tidy up after ourselves in a second, but for now, we're just going to say for season and season list, the base URL is that. That is no longer our base URL, actually, is it? What we're going to say is that this is called now league URL. Oh, let's call it data URL. I'm sorry. Let's call it data URL is that. And let's just check for ourselves that this works. So we're going to print data URL. And if we do that, we get out all of the data URLs that we are interested in. So what we now need to do, having satisfied ourselves that that exists, is we need to read in the data from those places. So let's just tidy up after ourselves. That works. Okay, and so we're going to say that the data frame is equal to pd.readcsv, and then we can just pass in the data URL. What we then have to do is we have to store these data frames, and we are going to concatenate them together. We're going to stack them one on top of each other. So we need to put those data frames into a list. So we need to create, to start with, an empty list. Let's just call it df list is equal to that, which is an empty list with nothing in it. And we are going to append to our list the actual data frame. Now, I love Python lists because you can kind of put in anything that you like. They're lovely in that respect. Dangerous, but lovely. I don't want to see you out there putting random things in a list. Like, here's an integer. Here's a list of like a data frame, an integer, and a dictionary. I don't want that. Try and keep your lists to exactly the same thing. But for now, we're going to stick these data frames into a list. And I will show you for why. Because we, having read all of these in, we can now look at the len of df list. And the len of df list is 5 long, as we sort of expect, because we've got 5 seasons. So we've read in 3 data frames. And if we inspect the first object in that list, oops, not df0, sorry, df list. Df list 0. If we inspect that, you can see it's the data frame that we would expect. It's actually the 2019-2020 data frame. Is that correct? Yes, it is. It's the 1920 data frame, which is great. But what we want to do is concatenate these things together. So at the end of all of it, what we need to do is that. So we're looking to, having got this list, append all of the data frames to each other so we have a nice big one. The way that this works is you can use a function in pandas called pd.concat, and that will take data frames or a list of data frames and shove them all together, and it looks at the different columns and it puts them into a stack. So we can use that method here. So we're going to say main df is equal to pd.concat df list, and if we let that run, what it's now doing is it's running through all of those 5 links that we've given it. It's creating that, and if we now inspect main df, we can see that it goes from 2019 all the way out to 2025, which is great. This is exactly what we need and want. We are now going to limit ourselves on the columns that we want, because we are only interested in some of these columns. And we want to make sure as well that the data is in order by date. So those are our next 2 things. It's not guaranteed to be in order by date at this point because we don't know how the data came in. We haven't inspected these properly. So we're going to make sure that the date column is of the correct form. It needs to be an actual date. And we're also going to get rid of some of these columns because we're not actually interested in all of them for the model that we're going to be producing. And you can see quite a lot of them are actually nans. So we just need to get rid of the things that we don't want. So as I say, what we're going to do is we're going to make sure that that column is a date, and we're going to order by it. So we go main df date equals main. Hang on a minute, we're going to use the toDateTime command in pandas. Main df date. And then we use the format command because we want to tell it what kind of format this date is in. And it is in, using the stirf time notation, it's in %d, %m, %y, because we are in Britain. So we go day first. And if we do that, we find that that date is properly formatted. It looks different to how it was now. It's now in the international notation of year first. And that's just the way that pandas is displaying the date now that that is an actual date time object. And what we can do is we can sort the data frame. I think this is how you do it. Sort values by equals date. I think that's how this works. Yes. So we can sort the data frame now by that column. It was probably sorted that way anyway, but it's really good practice just when you do have a date time that matters to turn it into an actual date time and then sort by that column, if that's how this works. So we need to actually set that as main df equals main df dot sort values by date. Okay, now let's have a look at the data and pick out the columns that we want. So let's just use the head command again. There are some columns in here that we don't care about. We're only going to pick out the columns that we want, and we're going to do some light transformations on them for reasons that will become clear as we model the data some more. But for now, there are only a few of the columns that we want. So we're going to make ourselves a list of that. We're going to call it col list. We want the division. We want the date. Let's code properly. We don't really care about the time because in football modeling, the time that the game takes place, at least for our purposes right now, doesn't matter because teams don't play multiple games on the same day. So I don't care what time the game happened. But what I do care about is the home team. I care about the away team. I care about the full-time home goals, and I care about the full-time away goals. I don't really care for purposes of this model, what the halftime goals were. It doesn't matter. I then don't care about the referees. We're not going to do modeling on shots. We're not going to do modeling on anything like that because we're building a very basic model here. So the only inputs to our model are going to be the goals that the team have scored now and previously, and ultimately actually we're going to look at what the opinion of one of the bookmakers is called Pinnacle, and we're going to reverse engineer their predicted score and use that to actually predict what we might want and need. For now, we're just going to select a few of these columns. So I'm going to tell you that we are going to want the PSH because that is the Pinnacle Sports Home line. We want the PSD because that is the Pinnacle Sports Draw line, and the PSA, which is the Pinnacle Sports Away line. So if we now were to use that list of columns and bring everything in, we would have a data frame that we could kind of like use. But we actually want a little bit more. So let me get a little bit more into the weeds of the bookmakers that are in this and show you what we're going to do. So these columns here, you can see B365 home, B365 draw, B365 away. These columns between here and here are all to do with the prices that bookmakers are quoting for the different outcomes of the game right about kickoff. And one of the metrics that we are going to use as to how successful our model is for predicting the outcome of the game is we are going to compare our results and simulate a betting strategy. That's one of the things that we are going to do. That's some way down the line, but we'll get there. However, what this means is that we need to pull in these bookmaker columns here. But I'm not actually interested in the individual bookmakers, because if you think about how we would, if we were to use a betting strategy, how we would express our opinion properly into the market, what we would do is we would look for the best price. We would shop around. We are not, or at least if you want to be a reasonably savvy bettor, we are not specifically tied to one bookmaker. We will shop around for the best price. So I am interested in statistics from these, or metrics, should I say, not really statistics. I'm interested in metrics from these bookmakers rather than their individual prices. So what I want to know from this set of columns is which bookmaker gives me the best price at the kickoff, and what was it? What's the average of all of the bookmakers' prices, and maybe what's the worst? I'm not that interested in what the worst was, but I really want to know, like, what is the best price I could have gotten and what is the average set of prices. So what we're going to do now is write some code in order to run through the columns that exist, these ones here, and figure out what is the best price I could get for the home, the away, and the draw line. So in order to do that, and I appreciate I'm hopping around a bit here, hopefully you are following along. That's very much the intention of these tutorials, is for you to kind of live code along with me. I'm hopping around a bit and we're all going to put it together at the end. But in order to be able to do the thing that I just said of the best possible price, we need to start with a list of bookmakers. So we're going to start with the bookmakers, which the ones that we're interested in are Bet365, Betway, which is BW. We're interested in a bookmaker called Interwetten, which is very much a Euro bookmaker that I don't have a lot of access to here in the UK, but, you know, I could if I wanted to. We're interested in Pinnacle Sports. We are interested in William Hill, and we are also interested in VC, who I have temporarily forgotten who they are. We'll look that up in a minute, but they are a bookmaker. They quote as prices. Having grabbed these bookmakers that we actually want, what we need is some empty lists, because we're going to create lists of the home columns that we're interested in, the draw columns that we're interested in, and the away columns that we're interested in. So we need home cols equals empty list, draw cols equals empty list, away cols equals another empty list. Okay, so what we're then going to do is we're going to iterate through the bookmakers and create these lists of the columns that we are interested in. We're then going to use some aggregation functions from pandas to figure out what is the average of those columns and what is the max of those columns. So we're going to run through. So for book in bookmakers, the home col is equal to book plus h, and then what I'm going to do is append that to that list. So home cols dot append home col. Oops, like that. We'll do that as well for our draw cols. Draw col equals book plus d, and then draw cols dot append draw col, and finally we'll do it for the away columns. So away col is equal to the bookmaker plus away, and then we need to append that to our list. So away cols dot append away col. If we inspect those now, let's make those lists just to make sure that we've not lost our minds somewhere. If we have a look at those lists, we should see that this is now a list of the bookmaker columns for the home price that we are interested in. So B365 home, Betway home, Interwet and home. Let's just check that that's true. B365 home, Betway home, Interwet and home, PSH, WHH. Yes, those are correct. Let's just verify for ourselves that the draw ones work as well, and the away ones have worked. That is all very true. Okay. Armed with these things, what we can then do is we can create new columns in our data frame for the maximum and the average odds of these bookmakers for each of their scores, and for each of their lines, the home, the draw, and the away. And the way that we do that is that we can create, so main df, we're going to create a new column called home max odds, and that is equal to main df. And then what we're going to do is we're going to take the home cols, we're going to give it a list, this list that we have created of the home columns, and we want to take the maximum of whatever's in those home columns. And the axis that we're going to do that across, we have to put in this keyword, which is axis equals 1 to tell it to go across the rows, not down the column. And let's put this one in, and we'll see what that result looks like. So main df now, if we inspect that, you will see right at the end that we have got in something called home max odds, which for this very first game is 1.15. And so let's go back and verify to ourselves that that is correct, that the score for the appropriate line for the max price offered for Liverpool is 1.15, and we can see that Bet365 we're offering is 1.14, Betway we're offering 1.14, Interwet and we're offering 1.15, as were Pinnacle, William Hill being stingy at 1.12, and VC, I still haven't remembered who they are, is 1.14. So yes, at kickoff, the best price being offered was by Pinnacle and Interwet, and that was 1.15. Ooh, really quickly, a note on this data set. You will see over here in this data set that there are columns called max home, max draw, and max away, as well as average home, average draw, and average away. If you read the notes on this data set, which again can be found if you go to footballdata.co.uk and you read the notes on this data set, they are just here, these notes here. If you read them, what you will find is that you should treat these max and averages with some form of caution, because the max basically means the max that was seen at any point in the lead up to that game. Not the maximum odds offered at kickoff by anyone, but the max that the odds ever got to in the run up to that game. Now you should treat that data point with some caution when you are modeling, because if you think about what that represents, there is no way that you would be able to catch that price knowing that it was the maximum, because you can't at any given time tell if the prices are going to go in or come out, like which way are they going to go. Without additional information, you're really not sure, so there's no way of knowing that you would grab that price. So when you use that, if you are going to use that in your modeling, use it with some caution. It's much better to use these ones over here, which are the prices offered near as damn it at kickoff. They are more challenging to bet into, they are more challenging to assess against, because in general prices get sharper and sharper and more accurate as they come closer and closer to kickoff. But hell, this is the game we're playing. So what we're going to do now is we're going to just add in all of the columns that we need. So main df, I would like the draw max odds, which is main df draw cols dot max axis. It's 1, and I want also the away max odds. Away cols dot max axis equals 1. So we've now added everything that for now we are going to need in our data frame. Let's pull all of this together and get ourselves a nice sensible output. So pulling all this together, we are going to need, so you remember from previously, this is our column list of all of the things that we're going to need. So what we're going to do is we're going to copy that and come all the way down here, and let's just replace this. Additionally, we know that we've made these 3 new columns, so we're going to need the home max odds as well. Oops, can't spell. We're going to need the draw max odds, and we're going to need the away max odds. So we're going to add all of these things in. This needs to be draw. And finally, we need the away max odds. So let's verify to ourselves that we can get these things. So main df of col list. This is a nice little data frame now that we can use. So we get the division, the date, the home team, the away team, the full-time goal, yada, yada, yada. All this good stuff. We've brought in these 3 things because of the nature of Pinnacle. We're going to use these guys for modeling later on down the line. The reason we are using Pinnacle for modeling is because they are a sharp bookmaker. They have a reputation in the industry for being extremely good with their modeling and reacting to market trends very, very quickly. So if you are after an accurate-ish price for how a football game is going to go, you can do a lot worse than the Pinnacle line. The final thing we're going to do is we're going to tidy up our code. Okay, this is now like typical data science territory. I've just got this notebook that's all over the place. It's got everything everywhere. Let's tidy it up and get it so that coherently we can run from top to bottom and get the data frame that we want. So let's start here. So we've got this season list, we've got a league. Let's take this function here and function, that's not a function, this line of code here, and put that into there so that we are turning the date into something cogent. We then sort values by date. We don't need this cell anymore, but we do need this cell. So we're going to take that, we're going to put it just here. Let's go in there like that. We then obviously need to create our max odds, which go just there. And then finally, we need our col list. So let's take that and put that there. The final thing we want to do is main df equals main df col list, like that. I know we're overwriting data frames. Don't at me. I don't care. It's fine. Okay. This is just some sample modeling for you to do. If you're being very, very particular, you could take snapshots in time and rename your data frame as you were going forwards, but we're never going to use that data frame again in this instance, so it doesn't particularly matter. And we have here the beginnings of a notebook. Can we get rid of that cell? Yes, we can get rid of that cell. That is completely fine. The beginnings of a notebook that we can start to use, having gathered much of the data that we need in order to be able to model football. So we're going to import pandas, like I say, and then we have the season list from 19 all the way up to 25, and we finish up with all this code with a main df, which has 1,791 games in it, all the way from 2019 to 2025, with the data that we need. In subsequent videos, what we're going to do is we need to manipulate this data to be able to start to produce predictions. So we're going to look into things like the Poisson distribution. We're going to look into how you reverse engineer the odds that a bookmaker gives you in order to be able to understand what their predictions were and compare yourself against their predictions. And then we're going to come up with some way and metric of analyzing the data that we have and the results that we predict. There will be some convenience functions we have to write along the way, so we're going to have to get into things like expected value and the Kelly criterion and betting strategy and a few other things like that. But for now, we are going to finish up this here, and I shall see you in the next video.